Before the forest starts screaming, it spends years holding its breath. Beneath the soil, below the dry leaves, roots, stones, fungal threads, and the buried remains of older seasons, cicadas live through the longest and quietest part of their lives. Humans usually meet them only at the loudest moment, when the air above the trees is vibrating with that electric summer chorus. But by then, the real story is already almost finished. For years, the animal has been hidden underground as a pale nymph, gripping tree roots with small hooked legs, feeding on xylem fluid, and growing in darkness so complete that sound, light, and open air are only future possibilities. Above it, storms pass. Fires may sweep the surface, animals migrate, leaves fall and rot, and generations of predators are born and die. The cicada remains below, almost invisible to the world, taking its time with a patience that feels less like insect life and more like a buried clock. This underground stage is not a pause, it is the main event. Cicada nymphs are not simply waiting in the dirt, they are plugged into the living plumbing of the forest. Their mouthparts tap into roots and draw from the thin, watery sap moving through the tree. It is not rich food, which is part of why their development can take so long. They survive on a slow diet, in a slow place, inside a slow rhythm. Their bodies are built for this hidden existence, compact, digging capable, protected from the open air, and tuned to the underground world where moisture, temperature, and root growth matter more than sunlight. In that darkness, the cicada becomes a reminder that not every dramatic animal story begins with a chase. Some begin as a quiet attachment to a root, years before anything spectacular happens. The soil above them may look empty, but it can be holding an entire generation in storage. In some places, especially where periodical cicadas occur, that hidden generation may be synchronized across huge numbers of insects. They do not rise one by one in a casual trickle. They wait until conditions align, especially soil temperature and seasonal timing, and then the ground begins to change. Tiny holes appear. Nymphs push upward through tunnels they have prepared from below. What looked like ordinary earth becomes a door. At dusk, when the light softens and many visual predators lose some of their advantage, the cicadas climb out of the ground and move toward trunks, stems, posts, and low vegetation. They are slow, soft, and vulnerable at this stage. A cicada emerging from the soil is not yet the loud, armored singer people recognize. It is a packet of unfinished wings and pressure-sensitive flesh, carrying years of buried preparation into one dangerous night. The emergence is beautiful, but it is also a massacre waiting to happen. Birds notice, lizards notice, spiders notice. Small mammals patrol the ground and pick off the clumsy climbers. Ants can find individuals that fail to climb high enough. Even fish may feed on cicadas that fall into rivers or floodwater. The cicada's great defense is not strength, venom, speed, or camouflage. It is excess. If thousands emerge together, predators can eat until they are full and still leave enough survivors behind to reproduce. This is predator satiation, one of the strangest forms of survival in nature. An animal survives not by being impossible to catch, but by arriving in numbers too large for death to process efficiently. It is brutal, but it works. The forest is flooded with food, and in that overflow, some cicadas slip through. Once the nymph grips a surface, the body begins one of the most delicate transformations in the insect world. The old exoskeleton splits along the back. Slowly, the adult pulls itself free, pale and soft, like something newly made rather than something ancient. Its wings are crumpled at first, folded into small, wet shapes that seem far too fragile for flight. Hemolymph pumps through them, expanding the veins and stretching the membranes until the wings unfold into transparent panels. The new body darkens and hardens in the air. For a while, the cicada is nearly helpless, hanging beside its empty shell while the night works on it. That abandoned shell, still gripping the bark with perfect little claws, is not just a creepy leftover. It is proof that the animal has changed worlds. The creature that lived underground has stepped out of its own body and entered the air. Then comes the sound. A male cicada does not sing with a throat. It does not call the way a bird calls or buzz the way a bee buzzes. Its sound comes from organs called tymbals, thin-ribbed membranes on the abdomen that buckle inward and outward with incredible speed. Each click is small, but the cicada's body acts like a resonating chamber, amplifying the vibration until it becomes that harsh, pulsing, metallic call that can dominate an entire woodland. To human ears, it may sound like background noise, an overwhelming summer engine. To cicadas, it is information. It helps individuals find one another. It separates species that may be calling in the same habitat. It advertises readiness, position, and persistence. It turns the forest into a living signal field, full of timing, competition, and reproductive pressure. The irony is that humans often call it meaningless noise because we are not the intended audience. The cicada chorus is not messy to the animals using it. It is organized by biology. Different species can call at different pitches, rhythms, or times of day, reducing confusion in a crowded soundscape. Temperature can affect calling behavior because insect bodies depend heavily on environmental heat. A warm day can turn the chorus intense, while cooler conditions may slow the performance. Some cicadas even regulate heat through behavior, choosing sunny or shaded positions, adjusting activity, and using the environment to keep their bodies within the range needed for calling and flight. The sound is not just loudness, it is physiology made audible, but the broadcast is dangerous. Any signal strong enough to attract a mate can also attract an enemy. Birds can track calling males. Predatory insects may move toward vibration. Parasitoid flies in some regions are known to use cicada calls to locate hosts, turning the mating signal into a trap. Even the act of calling exposes the male's position in a forest where almost everything is listening for opportunity. This is the central bargain of the cicada's adult life. Silence is safer, but silence does not reproduce. So the male becomes a living alarm, risking his body in order to be found by the right listener before the wrong one arrives. For the forest, cicadas are not just noisemakers. They are nutrient pulses, soil engineers, prey, root feeders, and sudden gifts of protein to almost every predator large enough to swallow them. Their emergence can feed birds during breeding seasons, fatten reptiles, support mammals, and even enrich the soil when uneaten bodies die and decay. Their tunnels help aerate the ground. Their feeding connects them to trees for years, and their death returns stored nutrients back into the system. A cicada is easy to treat as a loud insect that appears, screams, mates, and disappears, but that view is too small. The animal is part of a long exchange between root and soil, predator and prey, silence and signal. That is what makes cicadas perfect for the ghost frequency. The human version of their story begins when the sound becomes impossible to ignore. The real version begins years earlier, underfoot, where an unseen generation is already alive, already feeding, already counting the seasons through temperature and time. We walk over them without sensing the pressure building below us. We pass beneath trees that are quietly supporting thousands of hidden bodies. Then, almost overnight, the buried world surfaces. The ground opens. Shells split, wings harden, the forest starts to vibrate, and suddenly it feels as if the earth itself has found a voice. In the open country of Australia, silence is never really empty. It sits over the grasslands, the red soil, the salt bush, and the broken lines of eucalyptus, like a thin skin stretched across something restless. Heat rises from the ground in wavering sheets. Dry leaves scrape lightly against one another. Insects tick in the grass. Far off, a crow calls once and then disappears back into the glare. To a human standing there, the land can feel still, almost vacant, as if nothing is happening except sun and distance. But for the animals living inside it, the landscape is full of signals. Movement presses into the ground. Shadows shift across open space. The direction of a breeze carries scent. A shape at the edge of scrub can change the meaning of an entire afternoon. A kangaroo fits this world because it is built around distance. Its long hind limbs, heavy tail, elastic tendons, and powerful hips are not just dramatic features. They are answers to a continent where food and water may be spread thinly across hard country. A red kangaroo or large grey kangaroo can move with astonishing efficiency once it begins to hop, storing and releasing energy through its tendons like a living spring system. At higher speeds, hopping becomes less wasteful than it looks because the body recycles energy from each landing into the next leap. The tail, often treated as a background detail, is closer to a fifth limb during slow movement, bracing and pushing as the animal shifts forward. This is not a clumsy giant bouncing across a postcard. It is a specialist shaped by heat, space, scarcity, and the need to read danger early. That is why the thump matters. When a kangaroo slams its hind feet into the ground, the action is not random panic. It is an alarm with weight behind it. The impact travels through air as sound, but also through the ground as vibration. Humans may notice only the dull, heavy strike, a blunt noise in the dust. Other kangaroos are already reading more than that. They see the posture of the animal that made it, the lifted head, the frozen ears, the tension in the shoulders, the direction of its stare. They hear the rhythm and urgency. They feel the disturbance through the surface beneath them. In open habitat, where every second of warning can matter, the ground becomes part of the communication system. A mob of kangaroos does not need every individual to spot the predator at once. That is part of the advantage of living in groups. One animal raises the alarm, and the nervous system of the whole mob changes. Heads lift from grazing. Ears rotate. Bodies pause mid-feed. Young animals drift closer to adults. The entire group shifts from digestion to calculation. The thump is not just a warning that something is wrong, it is a command to pay attention. It compresses uncertainty into action. A fox near the edge of cover, a dingo moving low through scrub, a wedge-tailed eagle circling too deliberately above a smaller joey. All of these can turn grazing animals into a field of lifted heads. The signal is especially powerful because kangaroos live with predators that often depend on surprise, exhaustion, or opportunity. Dingoes are not mindless pursuers. They contest a mob, pressure weaker individuals, and use patience to find mistakes. A healthy adult kangaroo is not easy prey. It can accelerate quickly, cover ground with long bounding strides, and use its forelimbs, claws, and powerful hind legs defensively at close range. But young kangaroos, injured animals, and individuals caught too far from the group are more vulnerable. The alarm thump helps prevent danger from becoming personal. It turns a private sighting into shared awareness before the predator fully controls the situation. There is also a deeper physical truth in the kangaroo's body. It is built for heat, but never free from it. Australian open country can punish large mammals with temperature as much as with hunger. Kangaroos avoid the worst of the day when they can, feeding more actively during cooler periods and resting in shade when heat becomes dangerous. They lick their forearms, where blood vessels near the surface can help cool the body as moisture evaporates. They pant when necessary, but every cooling strategy has a cost because water is precious. Even standing alert under a hard sun is not free. When a kangaroo raises its head and stops feeding, it is spending time, energy, and exposure on the possibility of danger. The alarm must be worth it. That is what makes the thump so fascinating. It is not only fear made visible, it is risk management. In an environment where false alarms waste energy, but missed alarms can end a life, animals live inside a constant balance between caution and efficiency. If a kangaroo ran from every shadow, it would burn energy it cannot afford. If it ignored the wrong movement, it might never get another chance. The thump sits between those extremes. It warns without immediate flight. It says the world has changed, but not always that the race has begun. For a few seconds, the mob becomes a listening organism, gathering information through eyes, ears, muscles, and ground contact. Other animals may benefit from this alarm, even if the message was not meant for them. In open ecosystems, one species' panic can become another species' information. Birds rise when mammals bolt. Wallabies freeze when larger grazers become alert. Smaller animals may not understand a kangaroo's alarm in the same way another kangaroo does, but they can respond to the consequence, the sudden stillness, the direction of attention, the shift from feeding to readiness. The landscape becomes a shared nervous system, not because every animal speaks the same language, but because danger has patterns that many bodies can recognize. The kangaroo also reminds us that communication does not have to be delicate to be sophisticated. A foot striking earth seems simple compared with birdsong, whale calls, or insect choruses. But simplicity is not weakness. A thump cuts through distance. It works in dust, wind, and open space. It does not require a clear line of sight in the same way a visual signal does. It can move through the surface under animals that already live by feeling the ground with every step. It is physical, immediate, and difficult to ignore. In a place where the horizon can hide a predator until it is already moving, that kind of blunt warning has its own elegance. As the sun lowers and the heat softens, the mob begins to feed again. One animal bends first, then another. The tension drains slowly, not all at once. The ears still turn. The bodies remain angled for escape. The soil holds the fading memory of the thump, but the message has already done its work. Nothing dramatic may happen. No chase, no collision, no kill. And that is the point. Many survival signals are successful precisely because they prevent the scene humans expect to see. The predator stays too far away. The joey remains close. The mob keeps enough distance between itself and danger. To us, it may have been only a sound, one heavy strike in a wide, hot place. To the kangaroos, it was information moving through the earth. A warning without words, a pressure wave of attention. The outback for a moment stopped being background and became a broadcast surface. Fear passed from one body into the ground, and from the ground into many bodies at once. In that hidden channel, the kangaroo shows that the ghost frequency is not always high, strange, or invisible in the air. Sometimes it is low, blunt, and buried under your feet. A koala can look like the quietest animal in the forest. It sits folded into the fork of a eucalyptus tree, grey fur pressed against pale bark, claws locked into the trunk, eyes half open, as if the world is moving too fast to deserve attention. To a human looking up from the ground, it can seem almost inactive, a soft shape resting in the canopy while the real drama of the bush happens somewhere else. But that impression is a trap. The koala's world is not empty or simple. It is layered with messages we are poorly built to notice, deep calls moving through the trees, chemical traces left on bark, leaf choices shaped by toxins, body heat managed in silence, and social information written across the forest in ways that never need to become visible. The first surprise is the voice. A male koala's bellow can sound completely wrong for the animal producing it. It is low, rough, and strangely powerful, closer to a distant engine or a large animal growling through a hollow log than the call most people expect from a round, sleepy marsupial. That sound is not accidental theater. Male koalas have vocal anatomy that helps them produce unusually deep calls for their body size, and those calls can carry through woodland in a way that higher, thinner sounds might not. In the breeding season, the forest changes after dark. What looked like a still canopy becomes a broadcast network, with males calling from trees and sending information into the night air. The bellow announces presence, but it also suggests size, condition, and breeding status. It is identity pushed through the forest without the animal having to climb down and fight every rival face to face. This matters because koalas are not living in a peaceful postcard. They are solitary for much of their lives, but they still overlap, compete, avoid, investigate, and breed within a shared landscape. Trees are not just resting places, they are feeding sites, shelter sites, scent posts, and stepping stones through a home range. A male that bellows is not simply making noise because the night is quiet. He is placing himself into the social map. Females can hear him, rival males can hear him. Younger animals can hear a warning that the tree line ahead is already occupied by someone larger and more established. The call reduces some uncertainty before bodies meet. In that way, the koala's voice is not soft or cute. It is a long-distance management tool in a forest where direct conflict is costly. The second layer is even easier for humans to miss. On a eucalyptus trunk, a male koala can rub the dark scent gland on his chest against the bark, leaving behind a chemical message that may remain after he moves on. To us, that tree is still just a tree. Flaky bark, dry strips, maybe a strong eucalyptus smell in the air. To another koala, the trunk can carry a record of who has passed, who is active, and which parts of the area are being used. The forest becomes a notice board written in scent. It does not shout, it waits. A koala moving through the trees can investigate these marks and gather information without seeing the animal that made them. In a species that spends so much energy carefully choosing when to move, that kind of silent information is valuable. This chemical world is especially important because koalas cannot afford to waste energy casually. Their famous stillness is not laziness, it is survival economics. Eucalyptus leaves are abundant, but they are a difficult food, fibrous, low in available energy, and loaded with chemical compounds that many animals avoid. Koalas have digestive adaptations that allow them to live on this diet, including a large hindgut where microbes help break down plant material. Even so, the energy budget is tight. Resting for long hours makes sense when every unnecessary movement burns fuel gained from leaves that are hard to process in the first place. A koala sitting motionless in a tree is not failing to live dramatically. It is doing the mathematics of survival. That diet also shapes their relationship with the forest in a more selective way than people often imagine. A koala does not simply eat any eucalyptus leaf within reach, it chooses. Different tree species and even different individual trees can vary in water content, nutrients, and defensive chemicals. A koala must balance hunger against chemistry. The wrong leaves may cost more to detoxify than they are worth. This makes the animal's quiet feeding behavior part of a much deeper ecological negotiation. The forest offers food, but not freely. Every mouthful passes through a filter of smell, taste, learned preference, gut tolerance, and seasonal condition. The koala is living inside a chemical landscape, and its nose may be as important as its claws. Heat adds another hidden pressure. In hot weather, a koala may press its body against the trunk or larger branches of a tree, using the cooler surface to help manage body temperature. From the ground, this can look like ordinary resting, but the animal is using the tree as a thermal refuge, reducing the need to pant or lose precious water. In dry Australian conditions, water is not only something an animal drinks, it is something an animal must protect inside its own body. The eucalyptus canopy is both pantry and shelter, but also a kind of heat shield. The koala's stillness again becomes more intelligent than it looks. It is reading shade, surface temperature, wind, leaf moisture, and the cost of moving. Predators and danger are part of this picture too, even if adult koalas spend much of their time above the ground. Young koalas are vulnerable when dispersing, especially when they must climb down and cross open ground to reach new trees. Dogs, dingoes in some regions, large pythons, powerful owls, and eagles can all become threats depending on the habitat and the size of the koala. The forest canopy may seem safe, but it is not a sealed world. Movement between trees can expose the animal to everything waiting below. This makes the social and chemical map even more important. Knowing where other koalas have been, where suitable trees stand, and where a route through the canopy is possible can affect survival as much as feeding. There is also a strange intimacy in the way young koalas inherit their world. A joey begins life tiny and helpless, then spends months in the pouch before riding on the mother's back. At a certain stage, it consumes a special form of the mother's fecal material known as pap, which helps transfer gut microbes needed to digest eucalyptus leaves. It is not beautiful in the usual human sense, but biologically it is brilliant. The ability to live on eucalyptus is not simply born fully finished. It has to be prepared. The young koala receives not only milk and protection, but part of the microbial system that will allow it to enter the adult food world. The forest's chemistry is so difficult that even digestion has to be passed on like knowledge. When a male bellows at night, then rubs his chest against bark, he is adding himself to this layered system. Sound travels outward and fades. Scent remains behind and waits for a nose. Leaves advertise their chemistry silently. Tree trunks offer heat relief without announcing it. A mother carries a joey through a canopy full of edible danger. The koala's life is not loud in the way a cicada chorus is loud, and it does not strike the ground like a kangaroo alarm. Its ghost frequency is more private. It is a forest of low vibrations and invisible chemicals, a social world hidden inside what humans dismiss as stillness. That is why the koala belongs in this story. It proves that a biological broadcast does not always need speed, panic, or spectacle. Sometimes it is a deep bellow rolling through the trees after sunset. Sometimes it is a chest mark rubbed into bark. Sometimes it is a nose pausing over a trunk and reading what our senses cannot translate. We walk through eucalyptus woodland, seeing trunks, leaves, and a quiet animal curled above us. The koala moves through the same place and finds history, warning, appetite, heat, territory, and breeding opportunity layered over every branch. To us, the forest is scenery. To the koala, it is a living archive written in sound and scent. A manta ray enters the frame like something the ocean dreamed before land animals learned to walk. It does not slice through the water like a shark or flicker like a school of fish. It flies. Its broad pectoral fins rise and fall in slow, controlled waves, lifting a body that can be wider than a small boat and yet move with almost impossible softness. Sunlight breaks over its back. Tiny particles drift around it like dust in a cathedral. From a distance, the manta looks peaceful, even effortless, as if it has escaped the brutal calculations that rule most of the sea. But that calm is misleading. Beneath the elegance is a sensory world humans cannot enter, a layer of information carried not by color, sound, or scent, but by the weak electrical traces of life itself. The manta belongs to an ancient branch of cartilaginous fishes, relatives of sharks and rays, and like many of them, it carries a sensory inheritance that feels almost alien to us. Around its head are tiny pores connected to jelly-filled canals, part of an electroreceptive system often called the ampullae of Lorenzini. These organs can detect extremely weak electric fields in water. Every living animal produces electrical activity, nerves firing, muscles contracting, hearts beating, gills moving, cells maintaining differences in charge. To humans, that is invisible and silent. We can stand beside an animal and see its body, hear its movement, maybe smell it if the wind is wrong. But we do not feel the small electrical signature of life. In water, a ray can sense a reality we pass through blind. For some rays, this ability helps locate prey hidden beneath sand. A buried fish may stop moving, flatten itself, and disappear visually, but its body is still alive, and life leaks tiny electrical clues. Mantas, however, are not built like bottom-hunting ambush rays. They are filter-feeding giants of the open water, sweeping plankton, small crustaceans, and fish eggs from the sea with their mouths. Their electroreception is part of a broader sensory toolkit rather than a simple prey detector pointed at the sand. This is what makes the manta more interesting, not less. It shows how evolution can keep an old sensory system and fold it into a very different lifestyle. The manta is not a monster rooting through the seabed. It is a giant reader of water, combining sight, smell, flow, memory, and perhaps electrical information as it moves through a shifting ocean. When it feeds, the animal transforms. The rolled cephalic fins on either side of its head unfurl like living funnels, helping guide water toward the mouth. A manta may glide through a dense plankton patch, circle back again and again, or perform looping turns where food is concentrated. Sometimes individuals feed together, creating chains or coordinated patterns that make the water look choreographed. The prey are tiny, but the strategy is not simple. Plankton are moved by currents, tides, temperature layers, moonlight, upwelling, and the behavior of even smaller organisms beneath them. A feeding manta is following invisible structure in the water. To us, the sea may look like blue emptiness. To the manta, it may be full of gradients, trails, pressure changes, drifting concentrations, and the faint biological noise of a living soup. That is the strange truth of the ocean. Emptiness is often just information we cannot read. A plankton bloom can gather where currents collide. Small fish may rise at dusk in the deep scattering layer. Cleaning fish hold territories on reef stations where larger animals arrive to have parasites removed. Chemical traces dissolve and stretch through the water. Light bends with depth. Sound moves faster and farther than it does in air. Electrical signals fade quickly, but at close range they can add another layer to this already complicated world. The manta's grace is not passive. It is the visible result of a brain and body constantly sorting a flood of hidden cues. Mantas also remind us that size does not always mean aggression. They are among the largest rays on Earth, yet they feed on some of the smallest animals in the sea. Their danger, when it exists, is not directed outward in the way people expect from ocean giants. They do not have the stinging tail that many people associate with rays. Their power is in movement, endurance, sensory awareness, and the ability to exploit food so small that a less specialized animal would starve in the middle of abundance. This is an old ocean lesson. Survival does not always reward the animal that bites hardest. Sometimes it rewards the animal that can find the invisible feast. The manta's world is also social in ways science is still working to understand. Individuals return to cleaning stations where small fish pick parasites and dead skin from their bodies. These places can become meeting points, almost like service stations in the sea, where large animals slow down and allow tiny workers to climb over them. A manta hovering over a reef, while cleaner wrasses move around its gills, and skin is not just a peaceful image. It is a biological negotiation. The cleaner fish get food. The manta gets maintenance. Trust, memory, and repeated encounters may all matter. The ocean is not only predator and prey, it is also partnership, recognition, and routine, written into behavior rather than contracts. Predators still exist. Large sharks and orcas can attack mantas, and bite scars on manta bodies show that elegance does not make an animal untouchable. A manta's broad wings can help it maneuver, but they also create a huge visible shape in open water. Young mantas are especially vulnerable. The animal's slow reproduction makes that vulnerability more serious. Mantas give birth to live young after long pregnancies, usually producing only one pup at a time. This is not a species that can replace losses quickly. Every adult represents years of survival through a dangerous ocean, and every newborn enters the water already carrying the burden of being valuable. There is a quiet intelligence in the way mantas move through their range. Some travel long distances between feeding grounds, cleaning stations, and seasonal habitats. Their movements may be influenced by currents, food availability, temperature, and reproductive behavior. Like the green sea turtle, they cross a world that offers few obvious landmarks, but their navigation is probably built from multiple overlapping senses rather than one magic compass. Vision helps in clear water. Smell and taste can reveal dissolved chemistry. Mechanoreception can detect water movement and pressure changes. Electroreception may sharpen the close-range reading of living bodies and environmental cues. The manta is not following a single signal. It is assembling a map from fragments. That is why the electric sense matters so much for this chapter. It is not there to turn the manta into a fantasy creature. It is there because it breaks the human assumption that reality is limited to what our senses can describe. A still fish, a nearby animal, a living reef surface, the faint charge around moving tissue. All of it belongs to a hidden layer of the sea. The manta's head is not just a front end for feeding, it is a sensory gateway, opening into a world where life has texture beyond sight. As the manta banks through the blue, its underside flashes pale for a moment, marked with patterns that can identify individuals like natural fingerprints. Then it levels out again, cephalic fins curled, wings pressing against the water with slow authority. Nothing about it looks urgent, but the animal is not drifting through emptiness. It is passing through currents of food, memory, risk, partnership, and signal. Around it, tiny animals pulse in the water column. Cleaner fish wait over coral heads. Sharks patrol beyond the edge of visibility. Electrical whispers flicker too faintly for us to feel. To humans, the MantaRay looks like a silent shadow with wings. To the manta, silence is not empty. Water carries messages in forms our bodies never learned to notice. The ghost frequency here is not a sound and not a magnetic map. It is the faint electricity of life, the invisible signature that says something nearby is alive, moving, feeding, hiding, or waiting. The manta glides through that hidden layer with the calm of an animal that belongs to it completely. We watch the wings, the ray reads the water. Out in the open ocean, distance becomes almost impossible for the human mind to hold. There are no roads, no tree lines, no mountain ridges, no obvious signs telling one patch of blue apart from another. The surface lifts and falls in slow breathing waves. Sunlight breaks into silver scales. Below, the water deepens from turquoise to cobalt, then into a darker blue where shape and direction seem to dissolve. To us, this kind of ocean can feel empty, beautiful, and disorienting all at once. But a green sea turtle does not move through it as if it is empty. It moves through a world filled with hidden structure, currents, temperature, scent, light, wave direction, and something far stranger, the faint geometry of Earth's magnetic field. A young green sea turtle begins life in one of the most dangerous ways imaginable. It breaks from its egg under the sand, buried among dozens of siblings, then climbs toward the surface through a ceiling that can collapse, dry out, overheat, or be dug open by predators. When the hatchlings finally emerge, often under the cover of night, the beach becomes a battlefield measured in meters. Ghost crabs wait near the sand. Birds may arrive at first light. Fish patrol the shallows. The hatchling is small, soft compared with the adult it may one day become, and still it must move with urgency toward the brightest natural horizon over the sea. This first journey looks simple, but it is already a navigation problem. The turtle must choose the ocean before the land kills it. Once it reaches the water, the danger does not end, it only becomes larger. The hatchling enters surf that can throw it backward, pull it sideways, or bury it in foam. It swims with a frantic persistence, sometimes called a swimming frenzy, pushing away from the beach and into offshore currents. At this stage, survival depends partly on leaving the predator-heavy shoreline behind. Many hatchlings will not make it. Fish, seabirds, and other marine predators take them in huge numbers. The few that survive are carried into a life so wide that it seems almost impossible for an animal this small to understand it. Yet this is where the turtle's hidden sense begins to matter. In the deep blue, direction is not written on the surface. It is written into the planet. Earth's magnetic field is not a dramatic force to our senses. We do not feel it as a wind or hear it as a sound, but to many migrating animals, it appears to provide information that can help shape long-distance movement. Sea turtles are among the most famous examples. Research suggests that young turtles can respond to magnetic cues that vary across different parts of the ocean, using them as part of a navigation system that helps them stay within favorable currents and later return toward breeding and nesting regions. This does not mean the turtle sees glowing lines in the water, and it does not navigate like a machine following a perfect GPS route. Nature is rarely that neat, but the animal seems able to detect something humans cannot consciously read, a silent pattern spread across the globe. For a green sea turtle, this hidden map may begin early. The magnetic field differs subtly from place to place, with changes in inclination, intensity, and other features. A nesting beach may carry a kind of magnetic signature, not as exact as an address on a street, but specific enough to become part of an animal's inherited and learned orientation system. Many sea turtles show natal homing, returning as adults to nest in the same general region where they hatched. The precision is astonishing when measured against the scale of the ocean. An animal that leaves the beach as a tiny hatchling may travel across entire marine basins, spend years feeding and growing far from land, then later find its way back toward the coastline that began its life. The beach is not calling in a voice. It is held in memory through senses we barely understand. During its early ocean years, a young turtle may drift and swim within current systems that act like moving highways. In some ocean regions, floating seaweed mats and surface debris can become temporary nurseries, offering shelter and small food items while the turtle grows. The open ocean may look empty from above, but at the surface there can be a hidden community. Tiny crustaceans, fish larvae, jelly-like animals, drifting algae, and predators moving through the same floating shelter. The turtle's shell, small at first, becomes both armor and burden. It cannot outrun everything. It survives by moving, hiding, feeding, and slowly becoming too large for many of the mouths that once ruled its world. As green sea turtles mature, their lives often shift toward coastal feeding grounds. Adults are famous for grazing on seagrass and algae, and this feeding role makes them more than passengers in the ocean. They help shape the ecosystems they depend on. By cropping seagrass, turtles can encourage fresh growth and help maintain healthier seagrass meadows, which provide shelter for juvenile fish, stabilize sediments, and store carbon. A turtle feeding calmly in shallow water may look almost peaceful, but it is participating in the maintenance of an entire underwater landscape. The mouth that once belonged to a vulnerable hatchling becomes a tool that edits the meadow, bite by bite. Even adult turtles live inside pressure. Tiger sharks and other large predators can take them, especially in places where turtles move through predictable routes between resting and feeding areas. A turtle's shell offers protection, but not invincibility. Its survival depends on awareness, timing, and the ability to use the three-dimensional space of water. It may rest under ledges, rise carefully to breathe, and move between habitats with a slowness that hides real calculation. Breathing itself is a compromise. The turtle is tied to the surface for air, but much of its safety and food are below. Every ascent breaks the boundary between worlds, exposing the animal briefly to sky, surface glare, and anything hunting from the edges of visibility. The turtle's body is built around patience. Its flippers are not fish fins, but transformed limbs, shaped for long movement through water. Each stroke is smooth and controlled, almost like flight slowed down by the sea. Its metabolism allows long dives when resting, though activity, stress, and temperature change how long it can stay below. As a reptile, it is influenced by environmental temperature, and that connection begins before birth. In sea turtles, nest temperature affects the sex of developing hatchlings, meaning the heat of sand can shape the future balance of populations. The beach is not only a birthplace, it is an incubator, a danger zone, and a climate-sensitive decision point written into the animal's life cycle. All of this makes the turtle's hidden sense feel even more powerful. It does not erase danger. It does not give certainty. It gives orientation inside uncertainty. A current can push. A storm can scatter. Predators can remove entire generations before they mature. Beaches can change, erode, brighten with artificial lights, or become too hot. Yet the green sea turtle carries an ancient navigational inheritance through all of it. It enters a world with almost no visible paths and behaves as if the planet itself has left instructions in the water. That is the ghost frequency of the green sea turtle. It is not a chorus like cicadas, not a footfall through dry ground, not a scent mark on bark. It is quieter than all of them. It is the Earth's magnetic field, a signal so constant that humans forget it exists, yet so useful that evolution has built lives around it. To us, the ocean is a vast blue emptiness where direction disappears. To the turtle, it is layered with invisible information, some carried by water, some by light, some perhaps by the magnetic shape of the planet itself. The animal does not need a signpost. It was born into a map we cannot see. The blue whale does not enter the ocean like an animal. It enters like a moving piece of the planet. From above, only a long back breaks the surface, dark blue-gray under the shifting light, rolling through the water with a calm that almost hides its scale. Then the blow rises, a tall column of breath, warm and white against the colder air, and for a moment, the largest animal ever known to live on Earth is reduced to one visible sign. A breath, a back, a disappearing tailstock. Then the sea closes again, and the giant returns to the place where its real life happens, below the surface, inside a world where distance, pressure, darkness and sound behave nothing like they do in air. Humans understand the ocean mostly through its skin. We see waves, foam, weather, sunlight, and the violent edge where water meets rock. We hear surf and wind and the slap of chop against a hull. But beneath that surface is another ocean entirely, one shaped by pressure, current, temperature layers, and sound traveling through water with astonishing efficiency. A blue whale does not live in a silent blue emptiness. It lives inside an enormous soundscape where low-frequency calls can move through the sea across distances that feel almost impossible from land. The animal's voice does not need to be sharp or high to matter. Its power is in depth. Low sound can bend through water, pass through darkness, and remain useful far beyond the range of sight. This is what makes the blue whale the grandest ending for the ghost frequency. Earlier, hidden signals moved through soil, bark, scent, magnetism, and electrical traces. Here, the signal becomes ocean-sized. A blue whale's call can exist below the comfortable range of human listening, not always completely inaudible, but often so low and so shaped by water that we do not experience it naturally. Another whale may receive that sound as presence, spacing, movement, or breeding information across a world where visual contact is almost meaningless beyond short distances. To humans, the open sea can look empty because our eyes fail quickly underwater. To a whale, emptiness is a human mistake. The deep is not empty. It is carrying voices. The body that produces those voices is almost absurd in its design. A blue whale may reach lengths greater than many buildings are tall, with a heart often compared in size to a small car, massive blood volume, and muscles built for long travel through the largest habitat on Earth. Yet, its food is tiny. The greatest animal ever known survives largely by consuming krill, small shrimp-like crustaceans that gather in dense swarms where ocean conditions concentrate them. This contrast feels almost like a joke written by evolution, the biggest body on the planet, chasing some of the smallest animals worth eating. But the system works because the whale is not chasing individuals, it is exploiting abundance. When conditions are right, the ocean gathers life into thick patches, and the whale becomes a living net. Feeding changes the animal completely. A blue whale accelerates toward a krill swarm and opens its mouth so wide that the head seems to become a gate. Water and prey rush in together. The throat pleats along the underside expand, allowing the mouth cavity to balloon with an enormous volume of seawater. Then the mouth closes, the tongue presses, and water is forced out through baleen plates, leaving krill trapped inside. It is one of the most extreme feeding actions in nature. A giant spending huge energy in a single lunge, gambling that the patch of prey is dense enough to repay the cost. The whale is massive, but it still lives by calculation. Every dive, every lunge, every migration depends on whether the ocean has built enough food in the right place. Australia's surrounding seas can become part of this hidden machinery, where currents, wind, upwelling, and seasonal productivity bring nutrients toward the surface. Plankton blooms can grow, krill can gather, and large whales can appear in waters that looked empty only days or weeks earlier. The blue whale is not simply wandering through blue space, it is following productivity, often across huge distances, responding to the ocean's invisible engine. The food chain begins with sunlight and microscopic life, then rises through plankton and krill into the body of an animal so large it seems disconnected from the tiny organisms that sustain it. The whale is the final visible consequence of processes too small and too spread out for human eyes to hold at once. Sound helps connect that enormous life. In water, low-frequency calls are not decorative. They are survival tools in a habitat where individuals may be separated by vast distances. A whale cannot simply look across the ocean and see another whale. Light disappears, depth interferes, and the sea itself becomes a wall. Sound solves part of that problem. It travels faster in water than in air and can move far when conditions allow. Temperature layers and depth can shape how sound bends and carries, creating underwater pathways where certain frequencies travel more efficiently. A call entering that world is not just a noise, it becomes a moving signal inside the structure of the sea. For a blue whale, that signal may help maintain contact across distance, advertise presence, or contribute to breeding behavior. Males in some populations produce repeated patterned calls, and those calls can form part of a wider acoustic identity in the ocean. The details are still complex, and science is careful for a reason. Whale communication is not a simple dictionary where one sound means one human sentence. But the importance is clear. A whale's acoustic world is not background, it is social space. It is how an animal built for vast distances prevents the sea from becoming total isolation. Even the calf enters life through sound. A young blue whale is born already enormous by human standards, but beside its mother, it is still vulnerable. It must breathe at the surface, nurse on rich milk, and learn the rhythms of travel through water that may contain storms, predators, ships, and shifting feeding grounds. Mother and calf communication tends to be quieter and closer than the long-distance calls of adults, because attracting attention is not always safe. This is one of the most important truths about animal signaling. Broadcasting is power, but it is also exposure. A sound that reaches a companion can also reach danger. In the ocean, as in the forest, every message has a cost. The blue whale's main natural predators are few, but not imaginary. Orcas can attack large whales, especially calves or weakened individuals, and scars on many whales tell stories of encounters that did not end quietly. For an adult blue whale, size is protection, but for a calf, the ocean is still dangerous. The mother's body becomes shelter, guide, and moving boundary. Her choices matter: when to surface, when to travel, where to feed, how close to remain. The calf learns inside the moving shadow of the largest animal on Earth, while sound and touch help maintain a bond in a world where visibility can vanish within meters. Then there is the newer threat: human noise. Ships, engines, sonar, industrial activity, and other human-made sounds can enter the same acoustic world whales depend on. To a person above the surface, a ship may be only a machine crossing water. Below, it can become a moving wall of sound. This matters because the blue whale's ghost frequency is not mystical. It is biological and physical. If the ocean's communication channels become crowded, masked, or disrupted, animals that depend on sound may have to adjust. They may call differently, move differently, or lose acoustic space. The tragedy is that humans can damage a world we barely perceive, simply because we mistake our own sensory limits for silence. And still, the whale calls. Somewhere below the surface, beneath wind lines and whitecaps, beneath birds and boats and the bright moving skin of the sea, a blue whale releases a sound into the deep. The call travels outward into darkness. It passes through water filled with drifting plankton, hunting squid, passing sharks, sleeping fish, and the distant machinery of currents. It may fade, bend, scatter, or continue far beyond the animal that made it. Another whale, somewhere beyond the visible world, may receive it not as wonder, but as information. Someone is there, someone is moving. The ocean is not empty. That is the final meaning of the ghost frequency. Humans stand at the edge of the sea and think silence means absence. The blue whale proves the opposite. The largest animal on Earth is not powerful only because of its size, its heart, its lungs, or its ability to cross oceans. It is powerful because it belongs to a reality we mostly cannot sense. An acoustic planet beneath the waves, where voices travel through darkness and distance, becomes something sound can cross. Above the surface, there may be only wind, surf, and a quiet horizon. Below it, a giant is broadcasting through the deep, and the ocean is answering in frequencies we were never built to hear.